Hello everybody, and welcome to this Voltimum webinar. We've got quite a number of people that are already registered. There's been a few popping in the last couple of minutes, but I think we'll make a start so that we're not holding everybody in abeyance for too long. First of all, my name is Ian Richardson. I'm one of the group of the panel that's going to do the presentation this evening. Two of my other colleagues will introduce as we get in, and yeah, we'll just make a start. So, okay, that's me. So I'm with ABB, as you can see, and we've got a colleague here from Osram, Ben Brady, and Yasik from the Gerard group as well. So I'll be talking initially in the first part of the presentation about home automation, which is our topic for today. In particular, the title we chose is The Future is Now, and it pretty much says it all. There's been a lot of automation available for quite some time, and we have this vision of what automation could be at some stage in the future. But a lot of the imaginative ideas which have come up in sci-fi shows and whatnot is actually quite achievable already. When we're looking at an energy efficiency system or an automation home or building automation system, we're quite often looking a bit further than just a lighting system. It is an area that a lot of people think of, and when you first think of automation you think, fantastic, let's control our lighting and whatnot. But what we can actually do now with various systems which are available is we can control lighting. We can also integrate it with heating, ventilation, and the full HVAC system. We've got blind and shutter control available, security and monitoring systems. Moving to energy, we can control our load management at different areas depending on the circumstances. We can do load shedding as required, and we can even take measurement of our energy and pass that information through our network, which is our home and building automation system. I'm leaning a little bit towards a particular system with this, and that system is called KNX, which we'll have a look at in a little bit more detail, and the reasons why we look at that. As you can see, there's a couple of other areas there which is also covered in the home automation area. It's really anything to do with the management of the building is possible with a home and building automation system these days, particularly with something like KNX. Looking at the convergence of the applications that we've got, and going back in history a little bit, we've got our market basically divided up into non-residential and residential applications, and there's a series of other applications built in there: signalling, monitoring, HVAC, blinds and lighting. In the past, we had proprietary systems that were available, and some of them dedicated themselves specifically maybe to lighting, or they included some blind and shutter control as well. And then we had separate systems that were involved with signalling and monitoring. What's happening now is bus systems have come into being, and in the early days they were more in the non-residential space, but we're finding now it's becoming more commonplace down towards residential and non-residential. And a system such as KNX crosses those boundaries and goes throughout the whole spectrum of applications. Just got a question coming up already. Why would I choose KNX instead of a proprietary system? Yeah, very good system. Very good question, rather. One of the advantages of KNX as a particular protocol is the fact that it is not manufacturer dependent. So you're not at the whim of a particular manufacturer and what they choose to develop in their range. The KNX system, it is a protocol which is completely independent, and I think there's currently about 350 different manufacturers of product for the KNX system, and they all are guaranteed to work with each other. So having the multiple vendors provides a great advantage, particularly for the contractor, because if you're quoting on a project or something, you've got a competitive position there where a variety of manufacturers have all got their wares they want to sell to you, and you can negotiate some better pricing. So that's obviously a very good part of it. The other aspect of something like KNX is the standardization. KNX is actually a standard which is defined in the IEC standards. What the IEC standard does is actually define the protocol of how devices communicate with each other. And this becomes quite important when we're talking about multi-vendor. So that's probably the major reason why you might choose to go with something like a KNX system as opposed to other systems which are a particular brand.
Just click on that.
Okay, sorry for that delay. And just talking about standardization. So we can see here a series of different applications, and what's happened in the KNX world is we have applications such as lighting, blinds and shutters, security, energy management, HVAC, and there's a number of dedicated manufacturers in all of these areas who all have products which communicate on the KNX bus. So that means they can all talk to one another, and the system is actually guaranteed to work, which is a very, very powerful reason for looking at something like a KNX. And you can see down the bottom there's a variety of different standards, ISO, IEC, and the various European standards as well. So the multi-vendor approach of KNX gives us that powerful argument. To look at it in a different graphical way, here are a great long series of different applications that you might see in a home or a building application, and all of them can be covered through the one system. In this particular instance, we're talking KNX. One of the major reasons we might look towards having an intelligent system or a smart home or building is to try and save some energy. And there's been quite a variety of different studies that have been done worldwide in providing different forms of automation in different applications and the amount of energy that's possible to be saved. You can see here that obviously there's a huge focus on lighting, because you can save the greatest amount of energy by addressing an automation system associated with your lighting. So we can see up to 58% is quite possible. When we combine that with other applications such as a daylight harvesting system, blind control, your HVAC systems and so on, we can go into even further and much greater cost savings and energy savings. By the way, we've had one question come up. If you utilise the chat box, which I think is down the bottom of your screen, by all means ask a question as we go, and we'll address them as we are. Sorry, I skipped one ahead then. This slide here is showing a particular study that was done at a university in Germany, the University of Bremen. And it's an interesting study because it was done under reasonably controlled conditions, and we had two identical classrooms that one had an automation system and the other one didn't. So by adding various facets of automation, in this instance there's a couple of applications there, constant light control in combination with blind control, and then adding presence detection there as well. It was able to be recorded in this report to see exactly what type of energy savings. And in this instance, up to 52% was available, and also a huge reduction in the amount of energy required for heating or cooling. to map the classroom application here. So we've got a morning lesson going through, particularly looking at the heating involved, and admittedly this is in Germany where they have slightly different temperature variances that we might have here. But you'll see that normally you would heat up a room or heat up your building at the beginning of the day, maintain that temperature very closely to the parameters that you've got set, and at the end of the day or at the end of the evening classes as they have here, you shut everything down and it all starts again the following day. What we can do with an automation system is actually only heat the room according to the demand. So we're looking at when the classroom schedule is saying that the room needs to be used, and when it's not being used, we reduce the heat requirement down to a lower set point. Not necessarily turn it all the way off, because otherwise we've got a significant recovery that needs to be made. But the data tells us that a temperature reduction of about 1 degree can translate to an energy saving of about 6%. So you can see that there is significant savings can be made by maintaining our heating in a much closer fashion according to our requirement. Looking at a standard system, and again it's a bit of an argument towards a protocol such as KNX. There are literally hundreds of different systems available there. And you might have certain products that can communicate with each other, certain systems that communicate with each other. Different manufacturers have different systems according to their particular requirements and the way they've designed their particular products. So when we're looking at a total system in a large installation, and we might be looking, in this instance, you've got the installation, you've got shutter control, you've got the HVAC. The poor old customer has to contend with a variety of manufacturers and perhaps even a variety of systems, and try and link them all together so that they come up with a solution that they're looking for. Look at the same system but utilising a standard protocol such as KNX. You can see all of the products, all of the systems are on the same bus, and they can all communicate with each other. And it's a tremendous advantage when we're talking about these bus systems. The fact is that all of the items that you get, irrespective of the manufacturer, if it's a KNX device, it will talk to another KNX device, and it's guaranteed to do so because they've been 100% tested by an independent body. So as a manufacturer, and you saw at the start, I work for ABB. We've got quite a range of KNX products, but there are hundreds of other manufacturers that also have KNX products, and we've all had our products independently tested, so they're guaranteed to work with each other. And the good old argument, it makes it a very competitive situation when you're out there quoting on a job, looking for the best solution. You've got choice and you know it's going to work. So I find it a very, very strong argument. Another question there. I hear KNX has been around for over 20 years. Does it make it old technology? Interesting comment, really. Yes, KNX has actually been in existence for about 24 years at the moment. It was introduced in 1990. It's an independent thing. It's controlled by the KNX Association in Europe. I think the main response to the old technology so-called argument, KNX itself is the protocol, and it defines how devices talk to one another. Once you get to the device that's hanging off the KNX bus, that's where technology can change and can keep up with the latest and greatest developments. So all KNX is doing is, if you're going to be connected onto the bus, you have to talk to other devices in this way. And a further comment, same as TCP, IP and Ethernet. Yes, that's the method of talking. KNX defines how these devices actually handshake with one another. So to get the guarantee that a total system, being KNX, devices, a shutter controller will talk to a light dimmer, will talk to other devices as well. That's where the slight difference is on KNX. So that's a very brief overview. We're on a limited time, so I do need to hand over to the next speaker. So I'd like to introduce Ben Brady from Osram, and he'll continue with the presentation. And just one moment while we change over our headsets, and then you'll be listening to Ben. Thank you very much for listening.
Good afternoon, everybody. I'm hoping you can all hear me. Okay, my name is Ben Brady. I'm from Osram, Australia. I'm going to take you through specifically the lighting component. So dovetailing onto what Ian was mentioning before, we'll drill down into the lighting requirements and what can be achieved with lighting control. I guess from a holistic approach more than anything, we can see that lighting has a very large footprint in terms of energy consumption. In a commercial space or in any space for that matter, the target for us as individuals or responsible corporate citizens is to reduce that carbon footprint or at the end of the day save us some money. The way we want to achieve that is through lighting control. Now, if I can break it up into sort of 6 components, if we engaged all 6 of these individual strategies, we could, save up to 50 to 75% of the energy consumed in lighting. It's quite a sizable number. But we don't have to engage all of them, and this is the part of the message I'd like to communicate, that we don't need to complicate what is ostensibly a simple function of controlling a light in a room or in a space. I just got a question here. Is the consumption the same between commercial and residential dwelling? Look, it's the commercial side of things is a larger footprint. They've got generally more lights and longer usage times. But yeah, I'm talking in round numbers, just to give us a real idea of something that we can quite aggressively knock down the energy footprint by reducing the lighting demand or the energy demand related to lighting. So if I can focus on each of the strategies and give you a few insights into those. The first one, if we just call it task tuning, sometimes we also refer to as top-end tuning or top-end trimming. We all experience it day on day on day, spaces overlit. We don't always need to walk into a space and have the lights on at 100%. We can top-end trim it, knock off 10%. The human eye won't perceive that difference. However, very, very simply, we can reduce the energy saving without affecting the occupants, without over-engineering the space. And that can be done in a very, very simple and cost-effective manner without engaging a very large lighting control system, as it were. And if I can just reiterate what Ian mentioned also, if you've got any questions whatsoever during the presentation, by all means drop them into the chat box. Same as at the end of the presentation, any further questions, don't hesitate to make a comment. Okay, so task tuning, we're talking top-end trimming, so a real simple way of saving some energy, knocking 10% off the top end. Pretty simple way of going about it. The second method, personal control. Now that can be as simple as the light switch. as simple as a pot dimmer, a phase dimmer, or as complicated as PC control, where the occupant in the space can manage the light level in their space. It can be as sophisticated as turning the lighting control that's in the occupant's PC and can be made into a pseudo occupancy sensor. So we can really have a very, very simple approach, or we can really go top end. Another question has just come through. Isn't some of this legislated through the BCA? The BCA gives us, with lighting control, gives us adjustment factors to achieve an illumination power density based on the type of building and the type of space. When we're using now, this mad rush of LED lights, we can really light these spaces very, very efficiently. But that's the low-hanging fruit. That we really need to light these spaces efficiently and effectively. So, achieving these lighting levels using lighting controls is important, if not today, definitely tomorrow. I hope that answered your question. The next strategy that we can engage or employ to save energy is smart time scheduling. I think a lot of people who've had dealings with lighting control have used time clock, either scenes or just time clock on off. Very, very simple. Lights come on in the example on the screen, 6 a.m, lights turn off at 6 p.m. Again, we're saving energy. We're only turning the lights on and turning them off when the building space is occupied. Really very, very simple and uncomplicated way of going about saving some energy, making some dent into our energy consumption. The next and probably most common strategy is now occupancy control. So using sensors, PIR sensors. What I think we need to change our thoughts and feelings on occupancy controls or sensors. We need to consider them no longer as occupancy control, because let's face it, when we enter the space, the lights come on. When the lights are on, they're using energy. The important part of a sensor is that they recognize when somebody has left the space. So we consider that a vacancy sensor. So we need to ensure the lights turn off when there's nobody in the space. I know when I was a kid, my dad chased me around the house wanting me to turn off the lights when I'm not using them. I do the same with my own kids. I'm sure those of you with kids suffer the same problem. We also are all to blame in our working lives. We all walk into boardrooms or meeting rooms and the lights have been on for heavens knows how long. So if we engage a simple sensor, it'll turn off and on depending on the activities of the space. Again, a really simple, cost-effective way of reducing the energy through the smart control of the lighting in the space. Daylight harvesting. This can be standalone photoelectric or PE cells, or they can be integrated into motion sensors. They can be integrated into luminaires themselves. Using daylight harvesting, we can utilize the available daylight in a space to light the space for free. And then as that daylight diminishes throughout the time of day, we can then fade in or dim up our artificial light to light the space or to maintain the illuminance level in the space. That's using a dimming system. We can also again use a switching system that that actually prevents the artificial light from turning on when there's enough natural light in the space. Okay, these can all be used as individual strategies or used all together in a sort of a one holistic, very, very smart system. One of the more sophisticated ways using lighting control systems in saving energy is variable load shedding. So throughout the day, we're going to have different areas of a building, different parts of a building consume more energy, be it through heating and cooling, or heating and or cooling, the lighting, computers, you name it. And what we can do through the lighting control is we can dim some lights in some areas that don't require the illumination level. And again, like the first strategy, we can top end trim without affecting the occupants. 10%, the human eye won't pick that change up. However, the overall benefit to the building, or the energy consumption of the building, is a very positive one. Moving on, I think that's the last one. So that's my last slide. So I just, in closing, want to really reiterate that the 6 strategies that I mentioned, occupancy control, smart time scheduling, task tuning, variable load shedding, personal control, and daylight harvesting, we can use all of them. We can use some of them by very simple methods, or very highly engineered methods. So it's all very, very scalable. You can start in a very simple system and then add on, as a system like KNX allows us to do. So that's me. If you've got any questions, please use the chat box. Myself and Ian will be here throughout the rest of the presentation, so if there's any other questions through Yasik's Prezo, please don't hesitate to ask us. Thanks for your time.
Hi everybody, my name is Jacek Lippietz. I'm part of the Gerard Professional Solutions team here at Padso. I'm the business manager for outdoor lighting controls, and what I want to do is try to open your eyes with regards to other possibilities for home and building automation. And it's not only to do with what's inside the building, but also that you can do similar things outside the building. So exterior lighting control doesn't only, is one of the things that that I'm mainly focused in, and building automation can also refer to outdoor applications. What we have as examples are those for controlling of street lights, floodlights and architectural lighting. And if you look at a typical example of what you might find in Sydney is the lighting of the Sydney Opera House or the Harbour Bridge during the Vivid Festival. They use different types of technologies there. Most of it is what they call DMX for outdoor lighting control and theatre control. But it's a matter of beautifying the environment. But it is a method of controlling light. There's also other various methods for control. Now these, you would have heard of KNX as we mentioned earlier, but you've also got what they call power line communications, where signals are sent down through the 240 volt power lines. You also have wireless communications, where I think some of us may have heard of the terms of Zigbee and various things like that, as well as radio frequency, and you can also use 3G and 4G telecommunications. Additional to lighting, the connectivity can include various sensors, and these sensors can be such things as light sensors, rain sensors, motion sensors and traffic sensors. These kind of sensors can actually help you with dimming lights, turning them on or off, and be able to add to energy savings. A question I got was DALI, and if that's a common protocol. Absolutely. DALI is definitely a common protocol, especially used within interior lighting. It does have some place in exterior lighting, and it is used for addressing individual nodes, or nodes meaning light sources, and it also has the ability in most circumstances, not all of them, but in most circumstances, to be able to be dimmed. We at Gerard Lighting have our own DALI products. I won't be flogging those, but just so you know, they are available. Now, with regards to building automation and exterior control, this really does come down to offering you infinite possibilities. So what I'm trying to show in this rather complicated slide, if you tend to look at the very middle of it, we've got a web service, and one of the web services that we use is a product called Streetlight Vision. Streetlight Vision was particularly used for outdoor lighting control. It's the ability to offer you control of various power line communications, as you would see on the left-hand side, the LonWorks power line. There's quite a number of hardware suppliers there. So it's another system where there are a lot of suppliers and you're not stuck with one company. It also offers you the ability to communicate with things like solar panels. In Europe, they use them to communicate with electrical vehicle charging stations. We're yet to see that in Australia. You can also communicate with RF products such as the Philips StarSense. And there's really comes down to what your imagination is and what kind of communication you can have with what you can do with outdoor outdoor communication and smart building control. They also offer you multiple systems for being able to control this, which is mobile phone based, tablet based, computer based browsers. You can build your own applications to allow you to do many different things. Now my slides are very short and sweet. It's how I think it should be at the end of a presentation. But what we've talked about today is a particular type of communication protocol for home automation and building automation with KNX. We've talked about how we can save with regards to energy through lighting, and I've really briefly touched upon outdoor lighting control and that sort of stuff. And what I'm trying to lead to is that this smart homes and building automation all leads towards what they call the Internet of Things, or the Internet of Everything. This is bringing us as a world to a real connected area that we can control many different things. We can not only control lighting, we can not only control our HVAC systems, our blinds, our cooking appliances. We're able to communicate between meters for electricity, gas, water and solar panels. We can use that information to load share, such as extra electrical loads from homes. They can be taken on board by the electrical companies such as Osgrid, for example, and they are able to harness that energy and provide it towards the large factories which are straining the network. It's also a possibility to gather much information to lead you into different areas for gathering information for what people are doing with regards to your within the municipality, with regards to what kind of traffic is available on a road, whether the lights should be on or off and things like that. So the future really is mind-boggling. The ability to use this data can be controlled, and metered devices can be used, from everything, from energy saving through to advertising and road safety management. It's one of those things that whatever your imagination can come up with, it can be controlled in some way, form, shape or another. I believe that's pretty much my presentation. I did get a question, sorry. In the future, what about the systems that Apple, Google, Microsoft and Walmart are, and are these real and relevant? Yeah, well, I've been reading a bit about that as well. Graham, I believe, asked a question, and I think I've seen some of these things come through on Voltimum as some articles from overseas. Yeah, look, the people such as Apple, Google and Microsoft, they've got loads of money, right? So what I see as a personal opinion is that they have got the money to be able to invest in this. They definitely see this smart building and home automation as a way of the future. And so do I. I think it's a real benefit to all of us. And I believe that it will be like the VHS and beta kind of strategy. Who's going to win that battle? Will it be an Apple, a Google or a Microsoft? People need to start jumping on board. You need to think about what do you want to do, what do you want to use, what do you want to use it for? Do you want to use it for energy saving? Do you just want to use it in home automation purely to be able to control your TV, your lights, your air conditioning and your garage door from your Apple or Android device? These are the kind of things that we all need to consider with regards to home automation. But I think the message that we are trying to say is we need to jump on now. If you want to decide on using a particular product that's available out there, go for it. Before you miss the boat is my final little message. Do I have any more questions for anything, be it KNX, the lighting control, or the future of controls? Please put them in the chat question and answers box, and we'll do our best to answer these for you. If there's no questions, and before you go, we do have to offer you a survey. If you choose to do it, we hope you do. I might click on that now, or wait a couple of minutes. I don't like to keep I like to keep the airwaves quiet. I wasn't really a disc jockey, so. Right, so far it doesn't look like we're getting any more questions coming through. So on behalf of Voltimum and Ian, Ben and myself, I'd like to thank you all for listening. We'll be definitely happy to hear any of your responses that you have to these presentations, and if you have any questions, I'm sure going through the Voltimum site you can ask some specific questions if you were too shy or didn't have the questions to ask at the moment. So I'll just put you through to the survey. Thank you very much for your time.